So we are going to be going into, so we are going to be discussing chemical properties of halogen, right? Group 7 elements. We have already discussed the trends in their physical properties, right? The color, how their size is increasing, their non-metallic property. Can you recall what was the non-metallic property? Can anybody tell? Alishba, what is non-metallic property? Can you tell? What does non-metallic property mean?
Non-metallic property is uh, it is it gains electron.
Very good. It is an ability to gain electron. The more non-metallic property a metal has, the more ability of it, more it has an ability to gain electron, right? This is non-metallic property, and this is why the very good non-metals, the metals that are very good, like fluorine, chlorine, the group 7 elements are very good non-metals. And that is why they have a very strong ability to make other people lose electron, right? They are very good oxidizing agents. But as you go down in unlike metals in non-metals and in group 7 elements particularly, if you go down the group, what happens? If you go down the group, their non-metallic capacity, their non-metallic character, or their reactivity tends to decrease gradually. So fluorine is a very strong oxidizing agent, but but chlorine, then bromine, iodine, acetylene, they are weak oxidizing agents, right? So if you talk about chemical properties of group 7 slash generally non-metals, group 7 elements. When we talk about that, you're going to see that group 7 elements have the most non-metallic character, right? But their reactivity decreases down the group, right? Which means fluorine is most reactive, right? And then chlorine, bromine, iodine, astatine. So, or rather, we should be drawing them in order so that you can understand. Fluorine, you can say, is more reactive than chlorine. Chlorine is more reactive than bromine, which means more reactive. Bromine is more reactive than iodine, and iodine is more reactive than astatine, right? So if you're going down the group like fluorine, chlorine, bromine, iodine, astatine, if you're going down the group, more reactive and less reactive. Similarly, this more reactive, also you can also this greater than sign can also mean, it also means two things. It also means more stronger oxidizing agent, which means fluorine is the most powerful oxidizing agent and astatine is least powerful. agent, right? Which also means what? Also means that oxidizing power, oxidizing power decreases down the group. These are all of these are very important points. Definitely you're going to be having a lot of questions from this. And we know why. Why is all of that? Why is their ability to gain electron decreasing, right? Or you can also say fluorine is most non-metallic, which means it has the highest capacity to gain electron, right? And astatine most is least non-metallic in the group. Least non-metallic in group. In group. Do you understand?
जी sir.
Why? Because if you look at fluorine is in which period? Can anybody tell? Hmm? Which period? You should have this data booklet downloaded and printed and with you. Okay, data booklet should be there. It's in the one, two, three, third, second period. Yes, it's in the second period. Second period. It's 9, so it is 2, 7. So it's in the second period. This is in third period. Third. Bromine is in fourth, fifth, sixth period, right? So if you go down the group, the size is increasing. As the size is increasing, the electrons are getting further away, right? The electrons are getting further away from the nucleus, right? The valence shell. Why is this happening? The valence shell in which the electron is going to come, right? Valence shell in metals is what? Valence shell. When you talk about valence shell, basically, valence shell in metals, where the electron will go off from, right? And in non-metals, it's the place where the metal electron is going to come, right? Where the electron
Yes.
will come in and be accepted, right? So this is where it is, right? So I'll make you write this down. I just want you to understand this. The valence shell gets further away from nucleus. As it is getting further away from nucleus, the attractive force of the nucleus on the valence shell is reducing, right? We know that the nucleus is actually positive, and it is the one that is attracting electrons. Remember, it is the one that is attracting electrons. And as it is getting further away from the nucleus, the nucleus cannot exert a lot of force to accept electron, right? Who is the one that is accepting electrons? Because of the strong nuclear charge, right? The strong nuclear charge, as compared to the one in the third shell, right? let's say this is the first, second, and third. Which one is in the third? The chlorine, right? As compared to chlorine and as compared to fluorine, what do you think? Which nucleus has more power to accept the electron? The one with the chlorine or one with the fluorine? Fluorine, right?
Chlorine.
Because the nucleus is very near, even if the electron, it can readily attract and accept electron, right? But as the size increases, as the number of shells are increasing, it becomes difficult to accept electron for the non-metal. Why? Because the nuclear charge reduces down the group, right? The nuclear charge on the last shell is actually decreasing. All right. So this is what needs to be understood. So these are the few things that are going on with regards to the reactivity. Is this clear? We have not formally started discussing the
G.
chemical reactions that we have to do. This is something that I would want you to know. So what it is, group 7 elements have the most non-metallic character, but their reactivity decreases down the group, which means their non-metallic character, the non-metallic character decreases down the group, which means their ability to accept electron is decreasing down the group. And the reason is why? Due to increasing number of shells, right? And when we talk about the ability to accept electron, we are going to get in this point. Oxidizing power, which means the ability to make others lose electron and gain electron itself and become reduced, is actually also decreasing down the group. Why? Because they are losing ability to make others lose and get the electron back for themselves. Is this making sense?
Yes, sir.
Would you like to write or any of it, or you guys were writing with me?
We are writing.
All right. Which point?
सर हमने लिख लिया है, आगे बढ़ सकते हैं.
Right. Alijba, what about you?
The same, sir.
All right. So let's move ahead. All right. So now let's get into the main chemical reactions. Right. So we know fluorine is the most reactive. Down the group, the reactivity is decreasing. Fluorine is most reactive, then chlorine, then bromine, then iodine, then astatine. They are all non-metals. They all exist in diatomic form. Diatomic form, which means that there are two molecules which have made bonds together, like in this fluorine. Do you understand?
Yes.
Is this clear? This is how they exist, diatomic form.
Yes.
All right. So now the chemical reactions. The chemical reactions of group 7. We know group 7 elements, they gain electron and form and become anions, right? Like fluorine generally loses electrons, or you can say fluorine loses an electron to form a fluoride ion, right? You understand this point? Both of these equations are correct.
जी,
Basically, in reality,
yes.
basically the equation was like this: fluorine loses an electron to become fluorine ion. But this equation is wrong. Why? Why, Alishma? Can you recall? You cannot make chemical equations like these. Why? Because you cannot put a negative sign in a chemical
Because you
equation,
cannot put a negative.
right? You cannot put a negative sign, so you have to amend it, and you have to take this negative over there, and this is going to become positive then. You get it? Similarly, you can do that with all of them. All of them, they form anions. They become anions. They group 7 elements are called halogens, right? So when they form ion, their anion is called halide. Like what? Like fluorine loses an electron to become fluoride ion, halide, right? Similarly, chlorine loses an electron to become chloride ion, right? Chloride ion. Do you get it? Bromide, iodide, they're called halides, halide ion. All right. Is this clear?
Yes.
The next
Yes.
is the reactions. Number one, reaction with metals. Obviously, halogen plus metal is going to give you a salt, right? And this salt is going to be called a halide, right? An example: chlorine plus sodium is going to give you NaCl, which is called sodium chloride. It should be halide. Do you understand? Sodium chloride. We have already studied in salts. Remember? There were halides, carbonates, phosphates, nitrates. All of those were salts, right? So for the reaction with metal, they
Yes.
form. Similarly, bromine plus potassium is going to give you potassium bromide, right? So on and so forth. This is their reaction with the chemicals, with the metals. And all salts are what? Ionic compounds. Why? Because this is a non-metal and this is a metal. Non-metals and metals, they make ionic compound because there is an ionic bonding in it, right? And an ionic bonding, there are lattices. Lattices, remember? Lattices, ionic lattices. Remember? This is how it used to look like. Remember ionic lattices? So their reaction with metals. Then we have the most important one of them all. The most important of them all is the displacement reaction. This is what you will be asked most in your exam. What is the description? Most reactive halogen most reactive halogen displaces most reactive halogen displaces less reactive halogen from its compound, and reaction such reactions observe and such reactions observe a change in color. All right. Displacement reaction from its compound, or you can say most reactive halogen displaces less reactive halogen from its compounded solution, from its compound solution. All right, from its solution. Like what? Like we have chlorine is a halogen. We have, let's say we have Cl2 plus Cl2 aqueous plus 2NaBr aqueous. You're going to see that this is going to become 2NaCl plus Br2 aqueous. But how do we know this? We know chlorine. We know we can recall chlorine, fluorine, bromine, iodine, and acetylene, right? So fluorine is the most reactive, then chlorine. So if chlorine, a solution of chlorine, aqueous chlorine, is placed in a solution of sodium bromide, now this sodium bromide is a colorless solution. We know most of them are colorless solutions, right? Can you recall?
Yes.
This is also colorless. Ionic compounds. We know ionic compounds, most of them are colorless. All right. So if this is a salt, what you're going to see that this stays colorless. So this all of this solution in the reactant in the beginning is colorless. Then after you have mixed them together, you are going to see that NaCl is colorless. Again, the salt, aqueous. But this bromine is not colorless, right? Bromine is not colorless. Bromine is what? Reddish brown. Remember, we have already studied that. Reddish brown. So now the solution is going to turn from colorless to reddish brown. Reddish brown solution. Why? Due to the displacement of bromine from its salt, and this is due to displacement of bromine, yeah, bromine, and this is the element now, right? From its aqueous salt solution by chlorine. Is this making sense? So a higher, a more reactive halogen can actually displace more reactive halogen can actually displace a lesser reactive halide halogen from its aqueous solution. All right, and generally we observe a color change for that. Why? Because we know as you go down the group, the halogens they become darker and darker, right? Another example, if you look at it, and you have chlorine or bromine plus potassium iodide, right? Bromine, aqueous. Aqueous bromine is what? Reddish brown. This is colorless. So overall, this solution is what? Reddish brown, right? Bromine is more reactive. So it's going to replace, it is going to replace iodine, and it's going to replace iodine, and it's going to become potassium bromide, which is aqueous, right? And potassium bromide is colorless, but iodine is what? Brown in color. So overall, the solution is brown. So the solution has changed from reddish brown to brown due to